Alright, so let's put everything we've learned together. All that scientific notation math, and the significant figures math, and combined operations math. Okay? We can do this. And again, like I said, there'll be plenty of practice problems. It just takes practice, but if you struggle with this one, no worries. Let's go through it. So, the process is the same for the combined operations. So what we want to do first is order of operations, which means taking care of our denominator. Right? So we want to do this vertically. And whenever we're doing scientific notation math, remember what we have to do. Whoops, not what I was trying to do. What we have to do is take our exponents and make them the same before we can actually do the math, right? So I will take my 8 and make it a 7. How about that? So 8 to make it 7 means I need to go down towards 0, which is a reduction, right? So down is a reduction. That means a rightward movement. So that becomes 30.000 times 10 to the 7. So that's where I'll start. 30.000 times 10 to the 7th minus 1 times 10 to the 7th. Okay? So, very important that when we're writing all this stuff out, we're not adding decimal points or zeros or anything like that, because now that we know how important zeros and decimal points are to changing significant digits, we can't be adding them or taking them away in any fashion, because that will throw a wrench in everything. So, let's do this. Where are we going to draw our vertical line? Well, all of these zeros are significant because there's a decimal. So clearly we're going to draw our line down just to the right of our 1, right? So 30 minus 1 is, well, you guessed it, 29. Dot, right? Okay, so if you write all your zeros here, it's not going to change anything in this sense, because we're basically going to say up around here, it's still 29, right? So 29 times 10 to the 27, and that is seconds, is my denominator. So now we do our division. 3.02 times 10 to the 2k over 29 times 10 to the 27 seconds. Nice thing here again is that there was nothing here that we had to carry over because they're all zeros, right? No, not needing to keep track of any extra sig figs. So this problem is actually a little easier than ones we'll get in the future. Just don't forget, don't round until the end. Okay, so what do we do now? We count our sig figs. We got 2, we got 3. So our final answer should have 2. So division with scientific notation, you divide the front numbers, 3.02 divided by 29, 0.1041379, and then we take care of our exponents, right? We subtract in division. So we have a 2, we have a 27. That's going to be 2 minus 27, right? Oh, 27. Where did I get 27? I don't know where that 2 came from. Let's get rid of that bad boy. 27. Why did I write 27 up there? That should be just 7, right? 2 minus 7, okay? 2 minus 7 is negative 5 times 10 to the negative 5. Okay? Are we done yet? Of course not. Proper scientific notation. Okay? So, decimal point over to the right one place is proper scientific notation in this case. Right means a reduction, so we take this down more negative to negative 6. 0.1, what did I just do? 1.041379 times 10 to the negative 6. Now we round to significant digits. 2 significant digits. Keep it the same. 1.0 times 10 to the negative 6. And our units are kelvins per second. Practice, practice, practice.